In this video, I'd like to talk a little bit about IXL pre-calculus level F16, the exponential growth and decay word problems. We're actually starting off with an exponential growth problem that doesn't have an equation to work with. So let me share with you a technique that might be used to solve this type of problem. We're told that a town's population is currently 1,100 people. If the population doubles every 77 years, what will the population be 231 years from now? Well, what's interesting is that if we look 231 years ahead and we know that the population doubled every 77 years, we could divide these two numbers, and this tells us the number of times, this tells us how many times the population doubles. And as it turns out, 231 divided by 77 is exactly equal to 3. So the population will double 3 times. Now, knowing that, if we start with 1,100 people and we double it once, we can double it twice, and then ultimately double it 3 times. And this will tell us what our new population will be, which is 8,800 people. Now, to make this problem look more like an exponential equation, you may have noticed that this is 1,100 times 2 to the third power. That's also equal to 8,800. Now, this second problem is quite similar to the last, except we're dealing with what we call a half-life. In terms of chemistry, or biology for that matter, a half-life indicates how much time it takes for a particular amount of some substance to decay to half of what it started with. So instead of doubling in size, we're cutting in half in size. So we'll approach this problem much the same way. The half-life of this particular mercury is 47 days, and we're asking what happens 94 days from now. So in 94 days, for mercury that has a half-life of 47 days, tells me that there are going to be two, for lack of a better term, we'll call these two half-lives or half-lives in 94 days. When we start with 208 grams times a half-life twice for two of these, we see that we're left with just 52 grams. And again, this written as an exponential might look like this: 208 times, or 208 with parentheses around, 1/2 raised to the second power. And it looked like that answer was good too. So this next problem is just like those first two. I'm going to keep working on them until I see a different style of question. After about 4 questions, we made it to 36 points, and I now see a slightly different equation. Now, I'm a bit surprised that they didn't provide an equation for us, but let me share one with you that's quite similar to what we saw in section F17, and hopefully you'll be able to work through it for a few more future examples. Rather than using the financial form of this equation, I'll share this one with you. A is equal to P times 1 plus R raised to the nth power. Or sometimes we see this written as T. I'll leave it like that, as a T value. Where A again stands for the total amount of something after a particular amount of time. The total amount is equal to some principal or starting value times 1 plus our growth rate, the rate at which we grow, raised to the power of t, or the number of times, the number of years that we allow something to grow. In this case, we're told that there are 8,340 farmer markets this year. They are expected to grow at 5% interest. sorry, not interest, they're just growing at a rate of 5%, and this is being done for 10 years. So this expression would then tell us the total amount or total number of farmer markets that we would expect to see in 10 years' time. And this calculates to 13,584.9812, but our instructions did say to round to the nearest whole number. So let's go ahead and call that one 13,585. 13,585 farmers markets. And we're back to the same type of question we saw a minute ago. So let me work on this, and I'll keep working forward until I find a new style of question, and I'll come back and help you with it. Okay, so I made it to 81 points after 14 questions, and it looks like this is the first significantly different problem. This time we're seeing an example where a number is going down by a value. So in that case, we can accomplish that by, instead of adding our interest rate, we can change this to a subtraction. Therefore, if we had 83,822 subscribers, and the subscription was decreasing by 10% each year for 4 years, let's use a subtraction sign instead and calculate what the end result would be. And with my calculator, I see that that's 54,995.6142. We should round that, round it to the nearest whole number. So let's go ahead and call that one 54,996. 54,996 subscribers. And it looks like we're encountering another real similar problem. 5404 milligrams, decreasing by 25%, 8 hours. That one calculates out to be 541.01, rounded to the nearest tenth, so we'll call that 541.0. So again, a very similar question here. I'll keep working to see if anything changes between now and scores as we get closer to 100. I've made it up above 90 points, and it doesn't appear that the questions are changing all that much. Yeah, even at this point, it looks like we're getting the same answers. So I'm going to go ahead and stop the video here and trust that this will be enough for you to get quite a lot finished with this section too. Now on Monday, we'll spend some time looking at maybe some of the patterns that may have developed, some of the shortcuts that you may have learned while doing these practice problems, and also we'll talk about what it would take to work backwards and solve for a variable in the exponent. So perhaps we know how many items in this example were sold during a particular month, and we know what our growth rate is. Maybe we'd like to calculate how much time is necessary to reach a particular target. So maybe we'd want to know when we would sell 100,000 items, let's say. We could work backwards and calculate for the length of time. We'll talk more about that on Monday. Thanks for watching.